Hello. Hello. I'm audible. Hello. Hello. Very good. Very good students. Hello.
Good morning, ma'am.
Good morning. I will start. I will wait for some more time.
Uh, shall we wait, ma'am, or we can up to you, ma'am. Only
It depends on your convenience.
I'm ready, ma'am. If you start.
Okay. Yesterday, you people have attended the class.
Yes, I attended yesterday's class, ma'am.
What you have seen, can you little brief it?
Only few members have joined actually yesterday. Mm.
Yes.
And regarding water pollution and all that, classes went on till
Okay.
course 1 and course 2 went on.
Yes. So in course 1, about what I have discussed. In continuation of that only, I am going to talk.
Okay, okay.
So you
Uh,
little brief
Water
it, then
cycle
we will
regarding
also. Yeah.
yeah. The first class was about air pollution,
Okay.
air quality standards, meteorological station guidelines, and all that was taught for 2 classes. And
Okay.
from afternoon, course 1, water cycle, quality and quantity of water regarding harmful effects of water pollution.
Okay.
All that went on till 5 o'clock.
Okay, fine. Now I am going to start from water and wastewater treatment as per the schedule what they have given for me. The first half of the day I'm going to talk about water and wastewater treatment, and the second half of the day I'm going to talk about air pollution and control technologies.
Okay, ma'am.
That yesterday they would have covered that what are the sources of water, how to conveyance the water, what are the techniques involved in water conveyance, and what are the properties or characteristics of water. Then finally, what are the different stages of water treatment. I'm talking about water, not wastewater. Okay.
Okay, okay.
About
Yesterday,
these
lines of water is not discussed yesterday.
different stages involved in treatment have not been
Yeah,
discussed.
just only the headings. That's it.
Why I'm asking, if that is not clear, further remaining all units you may not understand.
Yes, ma'am. Yes, ma'am. Yesterday I was asking about that only. They told that today
Okay,
conveyance of
then
water
I will
will be
little brief
discussed.
it because that is very, very important for this particular subject, especially.
Yes, ma'am.
And, even I'm waiting for some more students that will be highly useful to all of you.
Yes, yes.
Very
We are
few.
unable to attend as we are working, no? So online classes will be helpful for us.
Yeah, then it is on Sunday only. Now I have preferred. I preferred to have it on Sunday.
Yes, ma'am, but don't know why. Yesterday few are joined, but today.
Send the message in group. You please send message or anyone of some people are in contact or touch with you. Please remind them to join because which what I am going to explain that will be helpful throughout the course to understand wherever the topic is coming. First point, and the second one is if you want to understand the entire theory of this particular paper, then you must know what are the different stages of water treatment. Second point. And the third point, if you are talking about environmental science anyway, just we'll see we are studying environmental science or anywhere you heard about the environment or environmental. So first it hit on your mind about air pollution and water pollution only, is it? You
Yes,
are
ma'am.
studying different papers, but those will not hit on our mind. First, it is strike that environment or environmental science or environmental science, whatever it is related to the environment means first it hit that about water pollution and air pollution only. So where the water pollution or what is pollution, what is water pollution, what is air pollution, and how it could be treated and what are the techniques are available to treat, because in air pollution you can say air is polluted or not, that's all, and there are different indexes are there, it is purely polluted or for moderately polluted, highly polluted, strongly polluted, severe polluted. 5 different indexes are there. That is called air quality index. But in water pollution, we have categorized that water is being categorized as a fresh water or water, and another one is wastewater. Earlier days, no need to treat this water, and we have to treat only wastewater. But nowadays, after 18th century, after this civilization and industrialization and urbanization, we have without treatment of any water, we cannot use it for human consumption. That is the situation. Under this situation, what we supposed to do? We must to know what is water. What is water means everybody knows it is H2O. And it looks transparent and also without color, without water. If it is there, we feel that the water is good, we can drink. Yes, of course it is correct, it is not wrong. But if we decide one particular source of water for human consumption means we must know that that particular source could be used for human consumption or not. If you select that source for human consumption, then what we supposed to do? How we can select the water source for human consumption? That you would have discussed yesterday, I hope. There are many water sources. What is the prime source or important source of water? Ma'am, shall I give 5 minutes? Can you communicate to your classmates to join if it possible?
Yes, ma'am. Wait for.
Okay.
Yes, ma'am.
Yeah. Then I will wait for 5 minutes or 2-3 minutes. Let them join. I will elaborate it. Then consequently, I will explain each stages of treatment because what they have covered the syllabus. What is water or what are the sources of water? And you have to identify the sources, water source. Then from the identified source, you have to convey the water. After conveying or before conveyance, after identification, you should know what are the characteristics of water or properties of water. Once you know the property, then you can decide that particular source of water can be used for water supply system. Then based on the characteristics, what are the treatment techniques you have to adapt? That is about the first unit or first block. And in that, if different stages of water treatment is there, and that is in, I think, unit number 4. Then after each treatment as a separate unit. That in unit 4, they will explain different stages of water treatment. All stages they will explain. Further, from 5th unit onwards, each stage of treatment will be the one unit. Until or otherwise, if you don't know about the water treatment stages, you cannot understand from unit 5 to unit 8. That's what I wanted to elaborate the different stages of water. Is it clear,
Okay.
ma'am?
Oh, clear, ma'am. Okay.
That's what I'm waiting. It is useful to every one of you. So I don't want you people to miss out this. Ma'am,
Yes.
I'm waiting. Please find out and let me know. I'll be
Yes.
on line on. I will not cut my call.
Okay. Okay.
Okay, ma'am. Yes, hello.
Hi, good morning, everyone.
Good morning.
Yeah, I'm not able to open that file, so that's why I have not joined in that link. So I'm happy now I am able to join this class.
Okay, thank you. So we'll start or some more people will join. The time is,
No,
Yes,
madam,
ma'am.
what was the
You can
schedule?
start. You can start, ma'am.
I
okay.
don't know. What was the schedule?
10:30 to it's 12.
12 o'clock one section and again we'll start the second section. Okay, no problem at all.
We
Now
can
what
go
we
through our
wanted to
schedule.
see, yesterday you would have seen water cycle, that this and all, no problem. But when we are talking about this water and wastewater treatment techniques, and the first two blocks is concentrated on water and water treatment. That means in water they have covered what are the water sources, available water sources. And in the second unit you would have seen that you have to select the particular water source and then how to convey the water from that selected source to the either treatment plant or to the distribution point. Then the third topic must be on what are the characteristics of water from the selected water source. And the fourth unit, that what are the characteristics, based on that characteristics you have to fix what are the steps or techniques to be adopted to treat the water. So based on that, the further unit is being designed. They will explain that each unit on how each treatment would be performed. So what is that exact treatment? What is the treatment? And what is happening when we are doing the treatment? And whether it is economically and technically feasible or not. What are the different types of particular types of techniques are available in that particular type of treatment? And about the treatment, what are the advantages and the limitations? Theory, what theory is involved? All those things that we covered in the unit 5 to unit 8. So before I start unit 5, that is about aeration, I would like to explain little about what are the different stages of water treatment. Any one of you can tell from that unit 4 what are the different stages of treatment, water treatment? Little fast, I'll give 1 or 2 minutes. Fast, you interact, I will explain more. It could be the interactive section. It is not the one-way teaching. It won't be looking good, then you may sleep in the middle. So to make it aware and awake, I may ask question in the middle, and it could be interactive. You people also ask me the question in the middle, whatever the doubt you have from what I'm going to speak. Then based on that, we will undergo. It could be the useful session like that. So please, can you, any one of you could explain what are the different stages of water treatment? Only stage you tell, no, it's more than enough. Yes.
Grit removal,
Okay.
sludge removal,
Okay.
and then activated sludge,
Okay.
and then drinking water, disinfecting the drinking water.
Okay, fine, good. So what is happening in grid chamber? Or in grid?
Coagulation, madam. Coagulation,
Yes, okay, coagulation.
later flocculation,
Okay, fine.
and flocculation is aggregation of all the particles together, and later when they become heavy, they get sedimented.
Okay, fine, good. Then,
And when sedimentation happens, we can pass it through a filtrate or filtration process.
okay, fine.
And to the filtered water, we can process it through different methods, like the disinfection or some kind of bleaching in case of public distribution system.
Okay, fine, good. Finally, what we supposed to do?
Finally, for conducive use, for human use and all, it has to be microbe free and pathogen free, and
Yes.
permissible level of disinfectant we need to use, like chlorine.
Yes, so that is
Yeah.
called disinfection or chlorination. Okay, very good, fantastic. Now we'll tell, I'll directly go to the treatment stages. You have selected some water source for water supply. That means either it may be dam or reservoir or lake or pond, whatever it may be. I'm not going to talk about what are the sources of this and all, they would have covered already. So you are selecting some source for water supply system. You have checked the characteristics, you have satisfied with the characteristics. Now you have to treat, you must treat nowadays, because there should be the link of or discharge of wastewater from municipality, or you can say sewage, and industrial effluents or industrial wastewater. And moreover, nowadays people are saying that due to this pressure changes and climate changes, there is intrusion of seawater into the soil that may change the groundwater qualities, and also slowly it may change the surface water quality. People have written in your book only. Somewhere I read. This is the concept. So anyhow, any resource or any water source people have identified for water supply system that could not be used directly, it should be treated. First, what treatment supposed to be given? If you take any water source, you could look at any reservoir or dam or pond or lake or running water river, anything you could see anywhere, not only in Telangana or Andhra, anywhere in the world you see, there must be something will be floating on the water. Is it? Something will be floated and something will be in suspension. So from that we can understand something would have mixed. Now for this I will ask the question, I'll keep the water in 3 glasses. One glass contained a clear water. There is no color at all. There is no flavor and odor at all. In another glass, I will keep the water with some sort of color. And a third glass, I'll keep the water with little turbid. Little turbid. Now I will ask you, from among these three glasses, which glass of water is clear? I'm not saying quality. The term I'm using, which one is the good water I'm asking? What you will answer? You will answer that the glass which one has the clear water, that may be the good quality of water, you will say, is it? Isn't it? I'm audible to every one of you.
Yes,
Hello?
ma'am. Yes,
Normal.
ma'am.
Yeah, you please
that could be the
respond.
normal assumption.
Yeah, then only I can go fast. Listen carefully. So we will say by look, we are saying that if something is colorless and odorless and then nothing is in suspension, that means suspension, or we can say without the turbidity, whatever you say, that is the good water you are saying. So first and foremost thing, when you decide the water source, the water supposed to be free from turbid and also from color and odor, is it? Now the turbid means what? The particle which are all in suspension in nature and also floating in nature, those are there, that is called a turbidity. And if it is not there, that is clear water. And in terms of color and odor, if you take, how the color and odor come to the water? What is the source of it? Any one of you could please? We are seeing industrial wastewater and also we are seeing sewage. What is the source for that color? Okay, leave it in industry, the sewage. For industrial effluent, what is the reason for that color? All industrial water may have color, it varies from pale yellow to dark brown. What is the source for that color? Any one of you could please little fast? Many of you are from pharma industries too. Okay, leave it. Wherever in any industry, the people are using organic matter or organic thing, which will have the phenolic compound, those impart the color to the water. Is it clear? Wherever or whatever the processing, wherever the processing is followed with or adapted with organic matter, those organic matters are having the phenolic compounds, the discharge of phenolic compound into the water, which imparts the color to the water. So the color is varied from pale yellow to dark brown, which depends upon how much concentration of phenolic compound is mixed or contribute the color to the water. So this is the source. Whenever those waters are free from all these three parameters, then we can assign that the water is good. This is the preliminary selection of any water source for water supply system. Is it? Now what we are going to do, first step of treatment, we first remove this turbid particle. How to remove the turbid particle? There are two methods. The substances which are all heavier than water are high dense than water, those particles will be settled down at the bottom. Is it? And some of the particles are bigger in size, but the density is less than water, they will be floating on the water. Those floated matter could be separated by simply screening process. The screening could be, because in your book, what they have stages in conventional water treatment plant they have given. But first step, they are sending raw sewage. You look at your page number on 58 or 59, I could not see. 58, 59. Stages in conventional water treatment plant, they have given the title below the figure number 4.1. But they are sending raw sewage. Could you able to see? Hello? That's what they did not. Yeah, that is totally wrong concept. Totally wrong concept. Please correct from your own book. You are not talking about the raw sewage, and they are given the details about conventional water treatment. Then they should have written that sewage treatment. If they have treated sewage, then it should be from the screen to grid chamber, it should come. If it is water treatment, means from the water, the floating matter supposed to be removed by screens. There are two types of screens are available. Those are all fine screen and coarse screen. Coarse screen will be useful to separate the floating matter with something like plant material, plant leaves, branches, and wooden logs, old clothes or useless useful clothes, including human body and animal body, could be separated or removed from the coarse screen. Don't think that whatever the water we are drinking, yes, of course, 100% that is pure and clean and treated water. And especially Hyderabad municipality water quality is the best one in India in many physiochemical characteristics, that we supposed to say thanks to God only. We are getting such a wonderful water because that water, whatever the water source they have decided and selected to supply the water, that those water quality is really good preliminary. They no need, they are treating the water, but not much aggressive treatment they are giving. So obviously we are getting good quality water. Now we'll come to the point. Anything could be possible from any river water, including human body, including animal body. It may be dog or cow or anything. Everything first they removed by coarse screen. So all that floating material which are all less denser than water could be removed by coarse screen. Then followed by fine screen. Followed by fine screen in the screen where they are using little bigger wire meshes or metal perforated metal sheets, and the a little smaller than the floating matter could be removed by fine screen. Then after what they are telling, now you please tell me, we have used coarse screen and fine screen to remove the floatable and less dense or high dense, then water will be removed to some extent. Then the particle really high density, then the water will be removed by sedimentation process. What is sedimentation? Anyone of you can tell what is sedimentation? Could you able to follow me, or I'm going fast? Hello?
Yes, madam.
I'm going fast. Could you able to follow me?
Yeah, it's no problem, madam. We can follow.
Okay, fine. Okay, fine. What is sedimentation? Anyone of you can please?
No, heavier metals settling at the bottom
Very good. Yeah,
due
whatever
to
the material, yes, sir, gravity. Very good,
gravity.
very good. The substances which are all heavier than water, water will be settled down at the bottom of the basin or tank, where the turbulence or the velocity of water is almost nil. The settling is happening due to the natural gravity only. This is called the sedimentation process. So after screening, the sedimentation is supposed to be done. So now heavier particle is being settled down. Then the clear supernatant or water is being subjected to the further treatment. What could be the further next treatment? The particle which are all heavier than water is settled down in the sedimentation tank, but some of the particles will be there, those who are very fine size, but they are all less dense than water. They still remain suspension in water. Those particles we supposed to remove. Those are all called collectively, especially in water treatment process, they are called colloidal particles. Those colloidal particles will be removed by the process called coagulation followed by flagellation. What they are doing, some of the chemicals, they are called coagulants, such as aluminum sulfate, ferrous sulfate, and ferric chloride, and polyaluminum chloride, and some of the chemical substances, when we are adding into the water, what will happen? The colloidal particle always has negative surface charge. That's what they are not interacting each other. When they are not interacting each other, they will be suspension in nature only throughout the life until or otherwise we do such a process. Those particles, when we add this coagulant, the coagulants are providing positive surface charge particles. So when they interact both together, the smaller particles will be aggregate and make the bigger one. And after mixing, once you have to add the coagulant into the water, and you have to mix it aggressively. After mixing, this interaction is happening between the coagulant and the colloidal particles. Then the particle will be slowly aggregate and which agglomerate into the bigger, heavier one. Then it will be eventually settle down at the bottom. Then it could be removed from the bottom of the tank. The first, when you are adding and mixing of coagulant, is called coagulation process. When you allow it to settle down at the bottom, which makes the precipitate which looks like a gelatinous precipitate. It is not very thick precipitate. You can look at that like a gelatinous precipitate. That precipitate formation is called flag. The entire process is called flagellation. And this flag could be removed. And the separation of flag and the clear water, this process is called clarification. Clarification means which is nothing but after flagellation, the clear water you have to separate out from the residue is called clarification. After clarification, we cannot say that all flag is entirely removed from the clarifier. Some of them will be in, it is possible to come along with the clear water. Those things we have to be filter it out. For that, the people are using their filtration unit. There are different types of filters are available, namely slow sand filter and rapid sand filter based on the process speed they have categorized. And many types of filters are available throughout the world. And all sort of filters people are using here and there based on the scale of operation. Then after the filtration, finally the people are doing disinfection when we decide the source for water supply system for human consumption. How they are doing the disinfection? Chlorine and chlorinated compounds are called very good disinfectant. They are adding in a particular proportion and they are maintaining particular the permissible limit in chlorine to maintain the quality of water till we consume 0.0 to 0.3, 0.2 to 0.3 ppm chlorine supposed to be there in the final treated water. When we reach that stage, it is being pumped and distributed to the end use. This is the process involved in water treatment process. Is it clear? Anything more you want? If you have doubt, you please ask me. I will explain here itself. Is it clear?
So what are the WHO standards for the drinking water?
It is there in your notebooks, sir, for pH, everything. Those things, pH supposed to be 6.5 to 8.5. Chlorine supposed to be 0.2 to 0.3 ppm. Each and every parameter must be there. It must be there in your book. Otherwise, I will send into the group. All those values, exact number I could not remember for all parameter, but I know if you want me to tell, I'll tell in the next class. Otherwise, I will send it as a file.
Okay.
Clear?
Yeah.
Yeah, the number, I really forgot the numbers. But for everything, the ISO standard, WHO standard is there, ISO standard is there, Central Pollution Control Board, they have their own standard, State Pollution Control Board, they have own standard. Some of the NGOs are having their own standard. Different organizations, they have own standard, but all are within that limit only. So ISO standard everywhere people are following. You can use in India. WHO is maintaining strict value, but anyhow all are in that border only. There is no much variation between one organization value to another organization value. So this is about the treatment process. Now what they are doing, I told you what are the major treatment stages involved in water treatment. Now some of the auxiliary processes are involved in that. For example, you take aeration. And you take some pre-chlorination, and somewhere people are doing pre-chlorination, somewhere people are adapted aeration also, somewhere people are introducing this activated carbon treatment process, and somewhere disinfection process, pre-chlorination already I told. These are all the auxiliary process people are adopting based on the characteristics of water. Now first I will talk about the aeration process. When I have explained the different stages of water treatment, I have not told about the aeration process. Why? Because that is not the major treatment process involved in water treatment. It must be involved in wastewater treatment. But in water treatment, it depends on the water source. If the water source contains organic matter. If the water source contains lot of solubilized or dissolved gases, solubilized or dissolved decomposable gases, then you have to adopt the aeration as a part of the process in water treatment process. Clear? What is meant by aeration? Until or otherwise, if these two problems are not there in water, you no need to adopt the aeration process. Is it clear? You please respond first, then I can go ahead.
Yes, madam.
I feel I'm going fast, and also I feel I wanted to cover the syllabus. Okay, whenever the water has lot of organic matter, and also whenever the water has lot of solubilized or dissolved decomposable gases, then only you have to adopt the aeration process in water treatment techniques. So what is meant by aeration? Otherwise, you no need to adopt this aeration technique. Okay, so this is the use of about the aeration only. I'm going to talk about another 1 hour. So I'll stop it here about aeration. Then activated carbon treatment, somewhere people are adapt. Why when we have to adopt the activated carbon treatment? Activated carbon is a good absorber. Wherever the water has color, the color is produced from either decomposable material or from the organic substances, whatever it may be, which imparts the color into the water. So this color removal is very, very important for especially human consuming water. If the water has color, will be used, we will reject the water. So the transparency or clearance of water is must or important for human consumption. So the color removal is important. Whenever the water has color, then you have to use the activated carbon treatment. Why? Because when you add the activated carbon into the water, whatever the coloring substances are there in water will be absorbed by the activated carbon, and color could be removed. If the water does not have color, means you no need to adopt the activated carbon treatment. Got it? This is second auxiliary process. And the third auxiliary process is pre-chlorination. What is pre-chlorination? Whenever the water contains lot of contamination. Anyhow, and all the treatment at last people are doing chlorination or disinfection, both are same. Pre-chlorination means previously at the end they will do, and also preliminary one more time they do. First they do the pre-chlorination and finally they do the post-chlorination. When they do pre-chlorination, when they are doing, when the water is contaminated too much by flowing or discharging of some industrial effluent or any dead bodies, animal body including human body, or a lot of litters or animal plant waste is there, that it must be degraded and decomposed, then it obviously which gives out a lot of population of microbes. When we come to know that from the odor and the color and some of the things we can, and from the organic matter load also we can understand that there will be a contamination or a huge quantity of contaminated substances are there, we can identify. In such a situation, there is a need of pre-chlorination. If such problems are not there, then you no need to do pre-chlorination process. So these three are very important auxiliary process. These three will be adopted whenever the problem is coming in a respective manner. Until or otherwise, these three are not followed. Now we'll talk about aeration process, which is one of the auxiliary process involved in water treatment and a major process in wastewater treatment. So anyhow, you should know exactly what is aeration, what is happening in aeration process, and what is going on in aeration process, what are the different types of aerators, and what are the limitation and the theory of aeration. Those things we are going to see in the unit 5. Till now, I am very clear. If people could be able to follow. If people have joined but not responding.
Yes, madam. Yes, madam.
Okay, now anyone, because if you are not responding, then I may lose my interest to explain more. Please understand from my side. So any one of you can say what is aeration, what is meant by aeration?
Adding air to water.
Very good. Then
which facilitates gas exchange
Okay, fine.
and oxidation process.
Very good.
Yeah, mainly water, because wherever organic matter is coming,
Yes.
there is more of carbon dioxide, methane, H2S, which gives order to the water.
Yes.
That is very, unpleasant, and that makes water, yeah, unfit for human consumption.
Yes. 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 Very good. Sir, what are you, sir? Can I know, please?
Me, madam, yeah, I am basically an advocate, madam.
Oh, fine.
Yeah,
But you are
but
talking about, yes, please.
yeah, we dealt with water treatment chemicals,
Okay.
and I happen to export these chemicals to African countries.
Okay.
Yeah, various process chemicals, not only water treatment, but for all industry.
Okay. Okay. That's what you are knowing all the process details. Okay, fine, sir. Very good. Thank you. Okay, now
Thank you.
we will talk about here. Sir knows all basic ideas about the process. Anyhow, very good. And here, sir, if you have any doubt on what I am saying, if you have any controversy, also you can counterattack. No issue at all. And if you have doubt, also you can clarify. Doesn't matter at all. I'm telling this to every one of you. Make use of this session. Should be useful. I have explained all the different stages of water treatment. Whether you understood or not, I don't know. If it is not clear, you please ask me. I will explain more. Now I'm going to start about aeration. Yes,
Uh,
ma'am.
yeah. Yeah, ma'am. Actually, one question was given on the backside of the model paper. Describe
Okay.
the sludge handling process, including thickening, dewatering, stabilization, and options for removal or reuse. Means the whatever you have now taught, that one we have to write, ma'am.
No, no,
Total.
no, no. Whatever you are talking about, those are all included in wastewater treatment, not in water treatment.
Okay.
Wastewater treatment that also coming in primary treatment. That is there in separate unit. I will explain. Today
Okay.
itself is possible. I'll explain. Otherwise, I'll explain in the next class.
Two questions are given basing on that sludge treatment only, actually. So,
Sludge means what? Sludge means the whatever the residue left over after the treatment is called sludge. Now
mm-hmm.
you are talking about the freshwater water treatment. The
Okay.
sludge is coming from this process, but the quantity is very less.
Hmm.
From wastewater treatment, you will get a huge quantity of sludge. Then you treat further, then you may have the energy value or economic value out of it. Then I will explain what are the process, what is happening exactly with the sludge. Definitely, I will explain. It is very, very important question also.
Okay, ma'am. Okay, thank you,
Okay.
ma'am.
Okay. Fine. Now we'll go get with the aeration. Aeration is a very important process, and this is being involved now with water and wastewater treatment. And what exactly is happening, whatever sir has said, it is correct. Actually, aeration, we cannot say this is a physical process or chemical process or biological process, which influences or covers with all three processes. Aeration is a physical, chemical, and biological process. Why we have to do, what is aeration? Aeration means you are just supplying or applying air into the water, and you are making interaction between air and water, and because of this interaction there is a formation of air water interface. When this air water interface forms, how many maximum number of air interface forms, that much utility of aeration is happening in the aeration process. Based on the interface, whatever the things will happen, whatever the soluble gases in water, the soluble gases are dissolved gases from either decomposition of any organic matter. Organic matter generally I am telling means that may be animal body, including human body, or plant material, or any industrial effluent, or sewage, anything it could be. All living things are organic matter. So any organic matter, when it decomposes or when it is degrading, which releases some of the gases called carbon dioxide, methane, ammonia, hydrogen sulfide, and some of the volatile organic compound. These 5 components are released. All the 5 are having the solubilized capability with water, but the proportion or ratio or the percentage will be different. These gases could be removed from the aeration process when air is supplied to the water, when air-water interface forms. At the place of air-water interfaces, in the middle, anything is there, it will be, we can say it is leaks out. It comes out of water. For that purposes, to remove of all these soluble or dissolved gases or decomposable solubilized gases, this aeration is very important. This is one aspect. And the second one is, when you are passing this air into the water, whatever the organic matter presented in water will be degraded from the complex structure into manageable form, easily manageable. All organic substances are complex structure except the fragments. Those complex organic substances could be break down into smaller compounds. Those compounds could be easily manageable for the further process. And this aeration process will be helpful, or it is make the further treatment very easy. What could be the further treatment? Either coagulation or it is filtration and chlorination process that will reduce the load of pollution or pollutant in those stages of treatment. And finally, which will be reducing the corrosion in the further treatment process equipment. All these are, and also sometime which is regulating the pH level, and sometime when we remove this organic matter or break down the organic matter during the aeration process, some of the microbes will be died. Some of the microbes will be died. How? You are breaking up, when the breaking up anything, so this decomposition process is exothermic or endothermic process? I told you that some of the things will be degraded, is it? And the complex organic matter is being break down into small fragments which could be manageable. Like that fragment is cut. So whatever the microbes will stick with that complex organic substances will be died. When it is died, the microbial population will be reduced. So these are all the things are happening, are use of this aeration process when we are doing treatment of water or wastewater. Clear? For that, in your book, they have explained technically, and whatever the gases are there, that is soluble gases or dissolved gases such as carbon dioxide or hydrogen sulfide, ammonia, and hydrogen sulfide, already I told you, methane, all those gases, especially when the carbon dioxide is more, then which lowers the pH. When it lowers the pH means where it increases, the acidity will be increased. Whenever the acidic pH increases, which makes the corrosion on the equipments. And also hydrogen sulfide is there, which produces, we know that is a rotten egg smell. And that also, rotten egg smell, hydrogen sulfide is also acidic in nature, that also makes corrosion. And ammonia, if ammonia is there, so ammonia also is one of the decomposable gases from the organic matter that will be highly interfere with the disinfection process. So what people are doing, what they wanted to do, they wanted to remove all these dissolved gases. And there are two techniques. When the gases equally, whatever the gases are there, these gases will be there in water. When you are supplying the air, when equilibrium stage is reached, the concentration of such gases more than the equilibrium concentration of air, the gases will be removed from the water. That is called the stripping process. Whenever the concentration of these gases less than the equilibrium stage of air in water, then those gases will be absorbed. So this is the reaction or concept is involving in aeration process. For this concept is being explained by one of the scientists called Henry. That is called Henry law. By following this Henry law, and chemically, aesthetically, the quality of water is being keep on increases. That's what we people are using the different techniques to convert this wastewater into useful form of water. And people are adopting this technology here and there to follow the same thing. Is it clear till now?
Yes, ma'am.
Hello? Okay, fine. Is it boring? Okay, I will ask some question. Then you people may be awake. Now you tell me that what are the reason for the color of water? I have told you already. What is the reason for the color of the water? Little fast.
The presence of organic matter.
Okay, specifically.
Yeah, like pale yellow, brown,
Okay.
and so when the color
Yes.
is pale yellow or brown, there is more composition of organic matter in the water.
Okay.
Yeah, and if it is other, it could be due to if it is green, it could be due to algae or other
It may be.
Have you
plant
seen any green color
like
water?
what, madam?
Have you seen anywhere water in green color?
Yes, ma'am.
Try the color.
So,
Don't say. I'm asking about the wastewater.
yeah, water where algae is present, then it will be more like green.
Okay. Yes, correct only. Yes, excellent. Then. Okay, fine. Actually, whenever the phenolic compounds are there, organic matters are varied from the aliphatic to aromatic. Whenever specifically the phenolic compounds are there, that only imparts the color to the water. Because acetic acid also color organic compound. Whatever the ethanol people are drinking, that also the organic compound. Methanol, ethanol, anything acetic acid formula, what we are using that called vinegar, that is acetic acid, that is also an organic compound. Drinking alcohol and fuel alcohol also organic compound. Those are all not in the pale yellow to dark brown color, correct? The color is being imparted by organic compound which are all in the phenolic compound. Phenolic compound. The phenolic compound only contributes to color to the water. And whatever sir said, it is correct. If there is a growth of algae anywhere in water or running water or stagnant water, that imparts the color. That imparts the color to some extent. That could be removed easily. If you remove the algae, it will be go. It will go. But if the light pale yellow to dark brown color, whatever is there, it will not go. You have to do the treatment. Compulsory you have to do the treatment. Then only the color will discolor it or decolor it. Otherwise, that will not go. That is only the difference between living things, what it gives, and non-living thing, what it gives. I hope you people could understand what I say. Is it not clear? Hello? Hello? If you have any controversy, please you can ask. Okay, then we'll come to the next step is aeration process. Actually, in aeration process, what is the theory involved? When we are supplying the gas into the air into the water, what is exactly is happening? The scientific concept behind that aeration is, first we have to understand aeration is a mass transfer process. What is mass transfer process? Where when we supply the air into the water, that air is bringing the equilibrium condition, and the kinetic is achieved by reaching this equilibrium condition only. And whenever the constant concentration of this dissolved gases less than the equilibrium concentration, whatever the dissolved gases will be expelled out, that is called or removed from the water, that is called the stripping process. or whenever the concentration of these gases is less than the equilibrium concentration of air, then that will be absorbed. If it is removed means, then we are telling that removal of dissolved gases. If it is absorbed means, what is happening means, whatever the organic matter presented in water will be oxidized or decomposed by this absorption process. Then if it is oxidized and reduced the size means, then organic load will be reduced. If the organic load is reduced means, the pollution